Hello, my name is Ryan Beam. I'm a student at the University of Kentucky studying economics and statistics. In this series, I'm just trying to explore how data is applied in the real world settings and how the field is evolving and is continuing to evolve. So, to help me dive into that today, I'm joined by Jaya Bhardwaj, a lead data engineer at Elekta, which is a medical technology company. Jaya has a successful career spanning various industries within the field. So, Jaya, thank you so much for being here today.
Yeah, my pleasure.
So, just to begin our conversation, could you walk me through your path into data and how you ultimately found your way into data engineering, especially coming from an education background that was more focused on electronics engineering?
Sure. So, the philosophy of my life is do what's best available for you. The next best thing will lead you into it, right? So, I started doing a degree in electronics engineering. I didn't know what's ahead of me. I kept learning. The only thing kept going is I'm a very curious person. So during my degree, I did a couple of internship, which was around control system, instrumentations, and um, more of a hardware type internship. And but for some reason, I was never drawn to those things. Um, then I landed up in a job which is software consulting job, and it was 2006 when I joined that company, and I got into a project which was pretty large scale project of converting and migrating a mainframe systems to web based RDBMS backend system. And during that project lasted for like 4 years, and during that project I learned quite a bit of things from the business aspect, and that made me realize how data is important and increasingly is going to be important at a rate that even it can beat Moore's law. And I can give you some examples like um, back then there was no role called data engineer. There were roles like backend engineer or database engineer, and what they essentially doing at that time was taking in third party feeds during offline window and processing feeds like claim, remittances, deposits, and you know processing them, matching them together, and that experience gave me my first glimpse into how large system exchanges data operate end to end, and what's the volume of that, and how our designing can make or break the whole intent of the system. So all of this um, um, sparked the interest in the data side, and that project lasted in year 2010, and then I joined another company, Bank of America, financial company. um, Pretty much I saw the same thing mimic in a different way, so but the whole idea remained the same, and it continued to go. I
Awesome.
hope that
Yeah.
answered your question.
Yeah, that's perfect. Perfect. That's
Mhm.
I've kind of seen some of that in the way I've approached it as well, just kind of trying to figure out what I want to do. And I see that data is super important and I feel like it's going to be super important going forward. So that's part of the
Mhm.
reason I wanted to get involved in something like that. So just kind of building on that, now that you're a lead data engineer with the company that you're at, how's your day-to-day work evolved compared to when you were just a data engineer or a senior data engineer?
So when you're a data engineer or senior data engineer, you're pretty much hands-on into coding, like writing small pieces of data or silos, figuring out how it makes from source to destination. But when you get into lead data engineer, you start solving scalability problems, non-functional requirement problems, designing systems, um, solving scalability problem. And I can give you a couple of examples. Like when I was a data engineer, I was simply doing data refreshes from one system to another system. I was given the tables and the structures, and I was pretty much designing the tables and the how the data moves from one place to another place. But if you move into a role like lead data engineer, you're thrown a problem like You know what? We want to solve IT infrastructure problem for moving this data. So you have the stored procedure SSIS packages taking care of mapping and everything. That's great. But how do we run them and where do we run them? And how could we bring the cost of running them to a level that it is scalable at a global level, right? So these are more of a non-functional requirements and more of a infrastructure problems that you start solving when you step into lead data engineer. So it's a combination of designing, understanding the IT infrastructures, um, seeing what's available, making choices. What do you want to put in a on-prem type solution? What do you want to move in cloud? Again, you're putting something on cloud, you have to be very cognizant of the cost, right? I don't want to choose some kind of service on the cloud which is gonna blow up my bills and then this solution is not feasible. So I think I'm probably all over the place, but these few examples gives you some idea on what is the difference.
Yeah, that's really insightful. Thank you.
Mhm.
And you mentioned the cloud there. So kind of moving on to more of the skills and programs and that side of things. You've been in data related roles long enough to see things evolve. How have you stayed adaptable through so many shifts, especially when things are going to more cloud-based engineering processes?
Yeah. So early on when I started, everything was on premise. Like you buy a box, you set up your softwares like SSIS, SQL Server, and you just scale horizontally. If you want more of them, you just put another box. You just keep doing that. But there's a bottleneck to that. And as we entered into era industry internet scale data, we introduced a problem of three V's. You know, data was coming at a very high velocity, it had variety, it wasn't a structured data, something was, text, unstructured, semi-structured, all sort of data. So variety. Um, um, so to solve these problems, now industry had to evolve and figure out a distributed computing system, right? And that is what is all the big data technology all about, Hadoop, HBase, um, spark spark on premise. But again, like, you can only, like, we can say that all these distributed thing will theoretically work in an on-premise environment, but if you think about the procurement side of this, today I'm running 5 parallel servers, and there is sudden increase in traffic because I did something miraculous in my marketing campaign or whatever, and my requests that are coming to these applications or servers spike up. I just can't go in like a matter of 6 hours to my IT department, get a server and scale it, right? So that's where the cloud technologies entered into this whole equation, and they say, we can give you scale on the go, right? If your requests are increasing, we'll scale your capacity. So it's all about staying informed what's going on in the industry. Make a habit of reading about something new every day. Sign up to the newsletters that are related to the field you are interested in. I think they are the perfect way to start your day. Get your coffee, open your newsletter. That should be very short, just cover one topic. And I think that's what keeps me up to date. And whenever we are thrown a problem in the team, you can suggest a solution that I think we should do it this way, and why, because of this. So that's what I have been doing all these years.
Yeah, that's really interesting, and that's some good advice. I might have to give that a try, looking at some newsletters that could keep me up to date on, the field of
Hmm.
data.
Hmm.
And going off that into the other tools and, languages, platforms you rely on most today, which ones do you think will matter most over the next several years if you could predict how things are going to evolve there?
Actually, we are on a cusp of a very interesting time. If it was 5 years ago, I would have given a completely different answer, but today my perspective has completely changed. So, um, anything for data, two things are very important: SQL and Python. They're just programming language and the query language, right? But then how your program interacts with hardware and how that hardware scales with the demand is also thrown in the problem mix, right? So I think the most important tools are um, automation, cloud native data system, platforms like Azure, AWS, GCP, modern data warehouses. So you don't have to, craft your own data warehouse. You just use one of them, which is already ready to go, snowflakes and things like that. Um, then orchestration tool, because you're having so many teeny tiny data pipelines that you want to put them together so it's easy for you to maintain, and you clearly see visually that I have these pipelines going parallelly, then one sequence, then two parallel and parallel of parallel, so orchestration is again very important to stay organized. um, and there's no single technology like skills in Python, SQL, cloud architecture. These things will remain essential. But since we are talking in 2025, the most important skill is critical thinking and reasoning. With the advent of generative AI, the more emphasis is on system design. Like you're thrown a problem, you communicate with your business stakeholder, they tell that this is my problem I'm trying to solve. So the most important skill that anyone should develop today is to be able to interpret the requirement, translate into a technical specifications, go to some LLM and start designing. We have probably 150 types of databases out there: NoSQL, SQL, um, so many orchestration tools, and each one has their core strength and weaknesses, right? So based on that small business requirement, you should be able to pick first the right technologies and then put them together in a way that all the Legos go together to build whatever you want to do. So today my answer is critical thinking and reasoning is the one thing you're gonna need. But if you asked me 5 years ago, I would say Python and SQL.
Yeah. Well, I really appreciate your perspective on that. I
Hmm.
think that'll definitely help, help me mold what I'm looking to do and how I'm looking to, what skills I need to pick up and the things I need to be conscious of when I'm moving forward with my career. So, and now just kind of shifting to the industry perspective. You've worked across finance, corporate tech, and now medical technology. What stood out to you about how the different industries approach data and data engineering?
Hmm. So, emphasis of each industry is a bit different. In finance, the focus is on accuracy, compliance, processing high volume with a high speed. In corporate tech, it's more about speed, innovation, and scaling the system as the demand grows. In medical technology, the emphasis shifts to data quality, security, patient safety, and the outcome, right? Outcome of the treatment. Um, so the priorities keep shifting, but the core engineering principle stays the same: that build a reliable, well-governed system that business can trust and get what they want out of that system.
Yeah, absolutely. When I've thought about data, and I haven't often thought about how that's different across the industries. I just kind of think of data in a vacuum, because data is data, but that gives me a great perspective to think off of. Thank you.
Mm-hmm.
And so just getting to some more just advice and general knowledge for students and new hires in data engineering. what do you see that they often misunderstand about the role or the field?
Hmm. So I think I'm gonna echo my answer again. So the common misconception about data engineering is, you're just supposed to write SQL and moving data around, and to get there, to be able to write the perfect SQL and move data around in a perfect way, it goes through several phases of rinse and repeat. So, you have a business stakeholder, then you have a subject matter expert, then you have a technical architect, team lead, and then the junior data engineers in the team. So, from business stakeholders all the way to the data engineer who are actually executing they're the little minions in the whole system. The main misconception is data engineering is just about writing SQL and moving data around. But in reality, as you're moving into AI era and phase, some of these layers are going to cut down. So if you are good at understanding that requirement directly from the business stakeholder and be able to execute just because you have power of AI, that is what is needed today. Nobody's gonna come and tell you like you have to write this SQL, this Python. Things have changed quite a bit in last 3 years. Is what. So I would say focus on communication, focus on functional, non-functional requirements, because non-functional requirement in the data field can be a deal breaker. Like things like whether my data is needed in real time or a batch, or a 5-minute batch versus a real time, right? So even even such decisions could be a deal breaker. For example, like the stock market cannot work on a 5-minute batch of data. It really requires that real-time streaming of data. Whereas if you ask me, a patient going from hospital A to hospital B because the patient is being referred, I think 5-minute batch processing will work, right? So having those conversations directly with your business stakeholders and understanding the end user's life cycle and what fits where, because if you choose a solution you're paying a cost for that. So optimizing cost, business need, and understanding how this change will make a difference to the business and the end user is what new hire should start thinking the data engineering from probably that perspective, because nobody is going to spend so many resources of the layers that I just talked about in today's world. So a vertical slice is needed at this moment.
Yeah, absolutely. Thank you for sharing that. Those are definitely some things I'll try to keep in mind. Um, so as we begin, wrapping up, you've had a long, successful career in data. What is it about data engineering and data itself that keeps you excited and passionate about the work you're doing?
Um, a lot of things actually, but I will try to keep it short. So what keeps me excited is that data engineering is consistently evolving. It's not boring. It's not monotonous. Always present you a new challenge. In whatever industry you are or whatever area you are, some challenges are faster than the other ones, but there's always new challenges. And I love building the system that turns the raw data into actionable insight and creates an impact. There were times when we were making decisions out of our gut feeling instincts, but that doesn't happen today. We need data to make any decision, even if it's a decision that probably costs $1,000 to a company. They want to look at the data, and it also data engineering is not just supporting the business stakeholders. There's different branches of data engineering evolve. Like any website you go, there's a small widget that's showing you some dashboard, and there's a big data pipeline behind the scene working. So even data engineering has been segmented, right? So you have so many different types of option even in data engineering available today that you could explore. um, so it's just it's the ocean. That's what challenges me. Yeah.
Yeah, that's I really kind of relate to that. The last part you said about just the, the wide aspects of data and data engineering, because I think that's something for myself that, I can see data in everything, and that,
Mm-hmm.
as somebody who likes a lot of different areas of learning and curiosity, I think data kind of acts as a bridge between them all, and that's so I really relate to that part.
Mm-hmm.
And just finally, as if you were in my shoes, a 19-year-old just getting into data, still exploring what I want to do with my career. What general advice would you have to give for me?
Mm-hmm. So I'll start with one liner that data engineering will always keep you interested, curious. You'll never be bored. And the advice would be to just follow your curiosity, focus on the learning skills and critical thinking, reasoning. Explore different areas, work on real projects, and don't be afraid of trying things out of your comfort zone. Experiences that you gather in early phase will shape your career far more than any single decision. Um, and I mean, data is gold. Every place needs data. These models needs data. These websites needs data. The business needs data. So it's everywhere. So yeah, that's what I'll say. Curiosity is what will keep you going.
Yeah, thank you so much. That's great advice. And I really just appreciate you taking the time out of your day to speak with me today. And I know I've gained a lot of useful information that I can use going forward. So thank you so
Hmm.
much.